Uh, ugh. Okay, so number 2, the answer is no. Is that a surprise? No. Right, okay, so we know that if you have a quotient, you just don't take the quotient of the derivatives, you actually have to do the derivative of the quotient. Now, how does that work? The quotient rule. If the functions f and g are differentiable and the quotient f divided by g is also differentiable, so when wouldn't that be? Like if g evaluated to be 0, we wouldn't be differentiable at that point, right? Then, but if the quotient is also differentiable, then f divided by g prime of x is equal to, here it is, the quotient rule, g of x times f prime of x minus f of x times g prime of x over g of x squared. Okay, you get to memorize this as well, right? So I just think of it, it's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. Okay, now you could also do it in this order. So some people think of it as the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator over the same difference, just the order of these guys, right? I don't necessarily know why you would do that, but I mean, it doesn't matter, right? Like, it's multiplication, the order you multiply in. In Leibniz, what is it, Leibniz? Leibniz. In Leibniz, I should know this, 2 years of high school German. But that was a lot of years ago. In Leibniz notation, g of x times d by dx of f of x minus f of x times d by dx of g of x over g of x squared. Okay, and use the functions of question 1 to verify the quotient rule. Okay, go ahead. Should be able to do that. I shall pause. And as was pointed out somewhat late, this is just a 6. Okay, fine. Now on to this. All right, so might as well record. Plus, wait, I've lost the formula. Minus f of x, 6x cubed plus 5x squared times d by dx of x squared all over g of x, which is x squared squared. Now, usually I don't do this. Usually I just go straight into the, here it is, but yeah, it doesn't hurt to show once in a while. 18x squared plus 10 minus so more often than not, just take this and go straight to this. Right? Just to show you, okay, this is what's going on. Okay, what do we got? 18x to the 4th plus 10x cubed minus 12x to the 4th minus 10x cubed 6x to the 4th, which is equal to 6, which now agrees with our corrected okay, so we good with that? Look, it works. Probably a proof in your book somewhere, I don't know. Yeah, the thing is, you would not use the quotient rule if this were the question you were given, right? You would just divide this out, right? And get 6x plus 5 and then do the derivative of that. Okay, so when you're getting questions, you think, oh, I got to use the quotient rule. And it's like, no, I don't, because this will go into both of those. That can be simplified, and then I can just use the sum and difference rules, right? Or maybe a product rule or something, okay? Because the quotient rule is not, terrifically easy one. All right, so do number 2. For example, 2. Well, Stipe Odds. Okay, so the ultimate simplified form is stuck up there on the upper right is 3 halves, right? 3x times x plus 2 over 2 times 3x plus 1 quantity squared. So, if you take it at face value, right? Like you just sit down and start, just hitting away at it, this is what you're going to do. Okay, then you get down to here, and it's kind of like, oh, okay, so I could take a 2 out of this, right? But there's 2 of them, so that's where the 4 comes from. Right, and 3x plus 1 squared and the 6x out of here. You could have, so dy by dx, you could take the constant out, right? So like, what have we got here? 3x squared over 2 times 3x plus 1. So we could pull the 3 halves out, right? And say it's 3 halves, dy by dx of 3x squared over 2 times 3x plus 1, and then work with this, right, which is ultimately going to end up with that. Yeah? 3x plus 2. What did I do wrong? Yes. Thank you. Let's clean that up. So we got 3x there and 3x plus 2. Okay, so you can take out. Nice. Come on, go back. You can take out the constant, right? 3 halves, and then be left with that, and ultimately end up with that 3x times 3x plus 2 over 2 times 3x plus 1 quantity squared. Okay, example 3. So we're going to kind of approach this from two points of view, right? So one is, let's just answer the question, right? Determine the equation of the tangent line to the curve f of x equals 8 root x minus 2x over x squared plus 1 at x equals 1. And then we'll come back to it later and we'll just do the general derivative of this, okay? But so for first, let's just answer the question. So knowing that we're going to substitute in a 1, we don't have to go into a big simplification process, right? We could just kind of lay this out and then substitute the 1 in and get our answer, right? The equation of the tangent line. Okay, well, we'll have to do 2 things, right? First, we'll get the, so what do we got to do first? We need to get f prime of 1, right? Okay, and then we need to figure out when x is 1, what's x, f of x, right? What's the y value when x is 1? Okay, easy enough, right? We're just going to substitute a 1 in to f of x, and we'll work out f prime of 1. That'll give us the slope. That'll give us a point. We'll use our favorite thing. We will find the equation. Okay, so let's do that. So what are we figuring out? F prime of 1. All right, so how does it work? It's the denominator, x squared plus 1, times the derivative of the numerator. Okay, so 8 root x. So that's 8x. Now I'm going to leave it as a root x because we're just going to be sticking a 1 in there anyways, right? So that's going to be, what, a half? So it'll be 4. No, hang on. So it'll be 4 over root x, right, that's that guy, minus 2, minus 8 root x minus 2x times the derivative of the denominator over the denominator squared. Okay, now, actually, let's call that f prime of x, but it's not in a simplified form. But it doesn't matter because we're just going to be throwing a 1 in there, right? So f prime of 1, let's go in and put a 1 in. Okay, what do we got? 2. 4 minus 2 is 2. 8 minus 2 is 6. 2. And what's 1, 2 squared. Okay, so what's that? 4 minus 12. Okay, so we got f prime of 1. We have the slope of the line we want to find is negative 2. Exactly left myself a ton of room to do this. I write real big. So the point we want is f of 1, right? So f of 1 is 8 root 1 minus, no way I can squeeze that. 8 root 1 minus 2 times 1 over 1 squared plus 1, which is what? 6 over 2 is 3. All right, 8 minus 2, 1 plus 1, 3. Okay, so we've got the point 1, 3, and the slope of negative 2. Y minus y1 is m, x minus x1. Y minus 3 is negative 2, x minus 1. Negative 2x plus 2, so we've got 2x plus 1 minus 5 is 0. Okay, so we good with that? We'll go through the other examples and then come back and say, so just do this, right? You got a blank page on the end. It's going to take a chunk of space to do that. And we'll say, let's just do this as a general, like find the general derivative, f prime of x, right? And just to look at, because there's something we got to handle, right? We got to handle this root x. Okay. If we want a simplified form. Okay. And oftentimes you're going to do these and then you're going to look at the answer and go, wow, like, is mine really this, just in a different form? Okay, and we'll look at, okay, so how are we going to handle that? But before that, algebraically determine the x coordinates of the points on the graph of the function g of x equals 3 minus 2x over 3 plus 2x, where the tangent lines have a slope of negative 4/3. Okay, so what do we have to find? What do we need to? Well, we need to algebraically determine the x coordinates. Okay, so how are we going to do this? Yes.
A general solution for f prime at x, and then make that general solution equal to negative 4/3, and then solve,
There you go. Yeah, exactly, right? So we need to get g prime of x, right, which we know is the slope of the tangent line. We're going to get an expression for that. We're going to set that equal to negative 4/3. We're going to solve and get the x coordinates, right? If we then had to find The points, the point itself, we would just put that x, those x's into g of x and get the y values. And if we had to do the line, then, you know, continue on, right? We would have the slope of negative 4/3. We would have these points. We would find the thing. But we're not in this case, right? We don't have to go that far. Okay, so g prime of x. Okay, so it's denominator times derivative of numerator minus numerator times derivative of denominator. When I do it, that's how I do it, right? I always just do denominator times derivative of numerator minus numerator times derivative of denominator over denominator squared. One of the other formulas had these reversed, right? You'd go the negative 2 times this minus, and then the 2 times this. You would do the derivative times, derivative of the numerator times the denominator minus the derivative of the denominator times the numerator over the denominator squared. And just watch when you're doing, especially the second term when you're expanding, just watch your signs, right? So this will be like minus 6 plus 4x. Okay, so. Okay, so I got my expression for my whatever, slope, g prime of x. Going to set that equal to negative 4/3 and solve for x. Okay, got as far as we need to go, right? We just to find the x coordinates of the whatever, it's off the page. So we have a general expression, right? We have g prime of x. We set that equal to negative 4/3. We cross multiply, solve using the square root principle, right? Because that was the easiest thing to do. And get two solutions, x is negative 3 or x is 0. Okay. We look back up here and we say, you know, there's a restriction here, right? What can't x be for this? Negative 3/2, right? Okay, which it isn't, so that's good, right? But that's something to keep in mind, right? Maybe we solve this and we say, hey, the point is this, and then wait a sec. Can't be that, right? So keep in mind your restrictions. Okay, so we know we have an asymptote, right? A vertical asymptote when x is negative 3/2. We also know we have a horizontal asymptote here, which is what? -1, right? No, you did that in 30-1, right? You could do it by inspection. And what would we do, right? We'd say, well, I want 3 over x minus 2x over x over 3 over x plus 2x over x, right? Limit as x approaches infinity, right? So as we head way out, which is the limit as x approaches infinity of, okay, what's that? 0. So we end, and this is just negative 2 over 2, which will be negative 1. Right? So that's the calculation. I mean, you can do it by inspection. You just look at it. Right? Or this is the way that we've done that, right? So, what, mechanical way, or it's an algebraic way of determining the asymptote. So we do have a horizontal asymptote at y equals -1, and we have a vertical asymptote there. Okay, and just keep that in mind when you're solving for these guys. Example 5. The equation of the function shown is h of x is 3x squared plus 4x over x squared plus 1. Algebraically determine the coordinates of the relative maximum and relative minimum. So what's happening here? How do we know where this is? or this. What do we know about the slope of the tangent line at this
the
point?
slope is equal to 0.
Yeah. Uh-huh. So what do we need? We need an expression for the slope of the tangent line, right? Which is h prime of x. When we've got that, we're going to set it equal to 0. Then we're going to solve. And we will find the x values. Then we will stick those into h of x, and we will find the y coordinate, and we'll have the 2 points, right? The relative maximum and the relative minimum. So, more quotient practice, right? Yeah, okay. All right, what do we got? 6x cubed minus 6x. Okay, so what is that? So we work our way through to h prime of x, right? We now have an expression for the slope of the tangent line. We know that at a and b, those slopes are 0. So we know that 0 is equal to, now 0 is really just equal to the numerator, right? The denominator doesn't enter into this. First of all, it can't be 0, right? I mean, the lowest that the denominator could be is 1, which is cool, right? Because it's x squared plus 1 squared. And it doesn't matter, right? The only thing that makes this expression 0 is when the numerator is equal to 0. So, all right, if I'm going to do this, I'm going to do it this way, and let's take 2 out of there. It's 3x minus 2. And what do we get? Minus 2 plus 1 squared minus 4 plus 1 minus 3. Yep. And I'm off screen, so I need this. 3 plus 4 over okay, and we just got to work those out, right? Okay, so what we got? 3/4 minus 2, 1/4 3/4 minus 8/4 And 12 plus 8 over 5, which is 4. 2, 4. Negative a half. Yeah. Okay. Right, so we've got our two values, x is negative a half or 2. We substitute those in and work out the y values. We get negative a half, negative 1, and 2, 4, which seem not unreasonable given the diagram, assuming there's some kind of a scale there. Close enough, exactly. The graphs of f, g, f prime, and g prime are shown. Determine the value of the following. So we've got f over g prime of 1 and g over f prime of, oh. Thank God. You should have seen the original one of these. It had like 1, 2, 3, 4, 5, 6. It had 8 of these to work out. Right? Seriously. Look, I sat down, I worked out 8 of them.
We only have 8.
What, do you have 8 too?
Yeah, 8.
Oh, all right. Well, guess what? Okay, so here's what I think we should do then, right? We got to do all of these. We need f of 1. We need g of 1. We need f prime of 1. We need g prime of 1. We need f of 4, g of 4, f prime of 4, and g prime of 4, right? So we're going to be using these a lot, right? So if we just sit down and write them all out now, then when we go through and expand these 8 things, okay, so what's going on? F of 1 is what? F of 1 is 4. Well, f prime of 1. F prime of 1 is 2. G of 1, red, G. G of 1 is negative 2. And g prime of 1 is negative 1. And we do the same thing here, right? What's f of 4? F of 4 is 8. F prime of 4 is 1. G of 4 is 4. And g prime of 4 is 5. Okay. So now that they're all there, it's really just a matter of expanding everything we see, right? So f over g prime is g of 1, f prime of 1, minus f of 1, g prime of 1, over g of 1 squared. Right? So that's really all you're doing for all 8 of these, right? Just expanding each of them out and then substituting in the values. So we'll do the first one together and then do the rest. So g of 1 is negative 1. F prime of 1 is 2. Minus f of 1, which is 4, times g prime of 1, which is negative 1, over g of 1. Okay, so what do we got? Negative 2 plus 4 over negative 2 squared. Oh, wait, just work that out. Negative 2 plus 4 over 4, which is 1/2. Methinks. I don't know. What did I mess up? Did I mess up?
G of 1 is negative 2.
G of 1 is negative 2. You're right. Okay. So, all right, I'm looking off of this, not that. G was negative 2, f prime of 1 is 2, minus f of 1 is 4, g prime of 1 is negative 1, and g of 1 is negative 2 squared. Okay, so we got negative 4 plus 4, 0. Okay, do the rest. All right, so I'm just going to leave this up for a little while in case you're looking at these online or somebody's looking at this online. At this point, just pause and then go through and look. And if any of you guys find anything wrong, let me know. Right, this is all good. And then I guess there's another page. Well, on here there's another page. Okay. I'm going to leave this up to record for a bit of time. And then I'm going to slide it up and do the last two because they're the most fun. Yeah, so, I mean, on a test, I could see giving you a couple. We're not going to give you 8 of these to do, right? I mean, but there'll be a couple. So just, you know, yeah, like 2. I mean, what's the point, right? I'll just give you like an easy one, f over g prime of 1, or maybe a 4, because it doesn't work out to 0, and maybe one of these bottom 2. I mean, if you do them, you can do anything in between. Right. Again, just remember what it is, right? It's just, I'm just getting an expression for the derivative using the quotient rule. Okay, so I'm going to pause, fill in the other. Okay, are those correct?
Sure.
Maybe.
If we're trusting my math, then
Maybe.
yes.
Oh.
I had the
Okay.
effort to do the last one, maybe.
If we're trusting, yeah, well, I was sitting there last night filling them in. I know, right? Like, I'd only done like 3 of them, and I just said, oh, whatever, I mean, you know. But that's why I suggest, like, if you know you're going to do a pile of them, that's why you list f of 1, g of 1, f prime of 1, g. Like, you don't want to keep looking up. Now, in a test, if you're doing 2 of them, you know, it's sort of a cost-benefit analysis. Is it worth writing all these numbers? Yeah, probably, really. Right.
I
It's
just spent 30 minutes figuring out which one's better and where the cutoff point is.
yeah.
Well, that's what you're doing the night
Where's
before you
the-
study.
Where's the point of no return? Okay, so what I want you to do now is, because you got a backside, right, which is blank, is let's do the general derivative. So if f of x,
No. Why do you do this?
because algebra is fun.
Yeah, opposite day.
Okay, so work out f prime of. Okay, so g of x times f prime, so that was 4 over root x, minus f of x times g prime of x over g of x squared. So there's our start, right? Everybody's going to have that, hopefully. So here's what we want to do. We want to get rid of that root x in the numerator. And the way we can do that is to multiply the numerator by root x and the denominator by root x. Okay. Now the question is, should we do that now, or should we expand the numerator out and then go through and multiply everything by root x? So upside, downside. If we do it now, we have to remember that we're really only going to multiply the root x into one of the factors, right? Say this one, obviously, and probably this one. Or if we can expand it out first and collect any like terms, so that we just have an expression up top, and then go through and multiply it by root x. So what's probably easier, is to expand it out, I'm thinking, right? Because that way you won't get confused and multiply this by root x and this. So I don't know. I don't know if it's 6 of one, half dozen of the other. So x squared, just remember that's an x to the half, right? So we're going to get 4x, so that's 4 halves, 4x to the 3 halves. So anything that's not a root x, we're just going to write as a power, right? X to the 3 halves in this case. Okay, anything that is a root x, we will leave as a root x, whether it's on the top or the bottom. Okay, minus 2x squared plus, so we're just going to leave this 4 over root x, minus 2, minus, what do we got, 16x root x, plus 4x squared. Okay, hang on. So this is going to be a 16x to the 3 halves, right? So then we can collect those guys together. So we've got this, and this, and this, and this. So we can collect some terms, right? Simplify it down. So let's go greatest powers of x, which will be what, squared first? So 2x squared minus 12x to the 3 halves plus 4 over root x. Okay, let me just, okay, so I've got an x squared. Doing these guys. Got this. Minus 2. Okay. So to get rid of the root x in the top, we're going to multiply by root x over root x. So f prime of x. So let's do denominator first. We're going to have root x times x squared plus 1 squared. And up here, so this is 4 halves times 1 half, right? So it'll be 2x to the 5 halves minus, what, 12x squared, yeah, minus 12x squared plus 4 minus 2 root x. And we can factor 2 out of the numerator, right? Which we could have done a moment ago if we had recognized that, but whatever. So 2 x to the 5 halves minus 6 x squared plus, well, let's put the root first. So let's go minus root x plus 2 over So I do this because what you see there is likely what you're going to see in the answer, right? If you look in the answer key, and you're going to be like, well, you know, what happens? Like, because I had a 4 over root x, right? Like I had that. So how did it become what it is down there? And that's how it became what it is down there, right? So recognizing and not putting x to the 1 half, leaving it as a root x, and that's a strategic decision, right? But doing anything that's not a root x as a power, doing like the x to the 5 halves and the whatever. Okay. So if you plug the original into Wolfram alpha and say, hey, give me the derivative, what you're going to end up with is what you see at the bottom. And if you didn't buy Wolfram Alpha Pro, it won't show you the stats, right? Yeah. How much does Wolfram Alpha Pro cost? What is Wolfram Alpha? Oh my God, like it's a computational engine. I don't know. So Wolfram Alpha is something you could say, show me planes that are overhead right now.
Due to interruption,
And it'll
the
do
owner
that.
of a black Ram truck, license plate BTN 0768
have this going out on YouTube, the black truck with license plate BPN 0678. Please go move your truck. Yeah.
Okay, can I leave then? I'd like to go.
Is I need to go to the washroom.